Good day, everyone. My name is Dr. Deyemi. In this video, I will be showing you how to generate tables and figures. Well, we'll start with tables alone here for survey data. Survey data is a little different from conventional data, in which case, in the survey data, you would have controlled for the weights in the data. And this will be important in a minute. But essentially, what this particular video will show is how to generate your tables for the purpose of manuscript submission. So let's dive into how to create the tables. First things first, and as I always tell everyone, you must always create your dummy table before you start your analysis. It helps a whole lot to create a dummy table because it sort of streamlines your analysis. This is a dummy table I created at the start of this analysis, and as you can see, there's a table 1, there is a table 2, and there is a table 3. Now, for table 1, the key information here in table 1 is the socio-demographic characteristics, in which reports the mean, median, standard deviation, interquartile ranges, or Q1, Q3, which is my preferred option. Or you also report your frequencies and percentages. Now, let me take you back to STATA. And before we dive into this, I want to explain why we need to take extreme caution when we are writing the tables for a survey data. Now, let's take sex, for example. Let's find out the population of male and female in this particular data set. Is a survey data. That means that it's collected using survey instruments across the population, and inherent in this data is a survey weights. And what it means is that they are using a small population to extrapolate the population of a larger society. Here, male is 1, female is 2. So it's telling us that we have approximately 32% males and 68% females. But then this is not taking into cognizance the survey weights. Now, when we apply our survey weights, I'm going to just run a code here. Um, let's pick this code here. It's already something I've done before, so I'm just going to show you how it works. So I'm applying this survey weights. Now, that's another video. I'll show you how to make the data survey weighted. But here, let's go with this for now. So now I've applied myself, I've made this data survey data. I can still go back and run my tabulation here, nothing changes. But if I want to really account for the weights here, what it means is that I will write my survey tab here. Okay, I can't use my M here. So let me just remove this M. And what it tells us is that it's approximately 68%. You can see it's just a little different, 68.05% for females here, 68.45% for females. So it's sort of adjust for the subtle differences. And this is actually going to be important when you do other analysis. Now, the goal of this video is to generate our tables and our figures. I have already run the analysis. I won't go through how the analysis is run. That will be a separate video. But essentially, what are we seeing here? When we run the the summary of ages and summary of chronic diseases, which are variables in this data, we can see that some of this information is actually generated in this particular do file, but we have much more than we need. going back to the tables and figures, what we need here is weighted percent and the count, unweighted count, and the weighted percent here. Unweighted count, weighted percent. Why do we have this? Because it tells the reader that this is the amount of people in the data set, but this is the percentage when you've adjusted for the survey design. Okay, now let's go back here and run some of the analysis and generate some of these tables here. So first things first, we can let's start with this particular column, all population, unweighted count and weighted percentage. In another video, I will show you how we generate this result, but the focus here is just selecting the appropriate numbers to insert into this particular table. So each category, let's start with each category. Each category is categorized as 0, 1, and 2. And let's see it here. Each category 0 is 64 to 65 to 74 years, 75 to 84 years, and 85 years and older. So I will pick, and we have here the observation. I'm going to scroll down a little bit so they can see what I'm talking about. So this is 1026. So those in 65 to 74 years, 1026. The next 851, 577. And these are the percentages. This is we are generating the percentage by column. So everything here adds up to 200. 41% plus 35% plus 24%. I'll go back to STATA and show you how this is done. So we'll change it to age cards. And you can see that on just using the age category, age card as a variable, we have these percentages: 41.1%, 34.7%, 24.2%. But we don't have the counts. So we can write additional information here, OBS. With OBS, which is observation, it will generate actually the numbers in each category for us. Now, if I don't have this survey tab and I just write tabulate age cards and I remove this, I can go control miss, adjust for missing, report missing. It's going to tell us that this is 34.68, just pretty much like what we have. But look at the age category of 2, 85 years and older. It's 527, but without adjusting for the survey weight, it's 23.5%. And here, where adjusting for survey weight is 24.2%. The same thing for those 65 to 74, 41.1 when we adjust for the survey weights. And if we do not adjust for the survey weight, 41.8%. So that subtle difference are important. Now let's go back to reporting this information. So for the first table, first column, the first column is just all population. So all I need to do is write this and then write this is the OBS here, is the unweighted counts. Unweighted counts. And the percentage here is the weighted percentage. How do I know? Because I've generated my code earlier that has, and this is the code. I will talk about how to use generate to do this kind of loop, because another way you can do is just write everything one by one by one. But if you want to be very parsimonious with your code, then you can write it this way and generate everything. So what does this tell us? For each variable of this variable list, and these are all the variable lists I selected. Each category is part of it. And then this is the instruction: survey tab VAR this way. And then I wrote my miss observe percent format. I wrote 8.0F. That means I want it to be rounded to the old number. I can actually change it to 8.1F, and that will also give me to 1 decimal places. So let's do this. I'll copy this here and go back to my do file. I can also run it from there, but let's do it here. So it runs everything for me straight away. Let me go back to my age category. And under each category, I have this. I can see what we have here: 1026,851,577, 41.1%, 34.7%, 24.2%. I prefer my tables to be written into one decimal places. So I'm going to create this so that I can see everything together. So here, 41.1%, I'll change to 1%, 34.7%. And then 577 will be 24.2%. And if you add up everything here, it's going to add up to 100%. And how do we know it's the column percentage? Because yeah, I mean, these are across the column. I've already specified the instruction in my do file saying that I want it to be in column percent. So this naturally, with this percent, the default would be the column percent. If I want another form of percent, then I will specify that. But remember, at this point, I'm not comparing anything. The comparison, low activity, high activity, will be at this point here. And we can continue this way. Let me go back to this file here, and then I'll look for another variable I've not done. So let's do race. I'll delete this. Well, I don't really need to delete it. 85.2% here. And then 200, which is here. 200 is here. I can follow my cursor. 206.4%. Then move this a little bit to the side. Move this a little to the side. And then this here. Okay, good. So, and then we have 173 and that 5.0, perfect, no changes. 119, and then that's 3.3%. 3.3%. So I have all of this sorted out. Let's do the male and female again. I can scroll back up a little bit. Male is 1, female is 2. And how do I know? Because I coded this data. So, but in subsequent videos, I will show you how to put labels to your variables, and that will help everyone looking at your data. So 784 and 68.4. I'll do one more here. Let's do which variable do we have? Educational attainment, EDU. So educational attainment, high school or less, we have 216, and now open parenthesis, and then write 9.1, close parenthesis. Some college, that is 296, open parenthesis, 12.8, close parenthesis, and 640, that's for the bachelor degree, open parenthesis, 26.0, close parenthesis, and then the last one, postgraduates, that's 521. Sorry, 1302, 1302, and then percentage will be 52.1%. So now this pretty much sorts out how you populate this particular column. But then let's now go into this second column, low activity, high activity group. Then I go to my do file again. I have a code that sort of fixes that. This is just the same result as we've seen there. So now here, let's look at this line of code 477. For each of these the same variables, and then I'm writing tab var, and then the category is low met class. That means that low is 1, and then not low or high activity is 0. So this is what I am creating here. I can copy it here, or I can run it directly. If I want to run it directly, I can just run it from this play button here. I've highlighted this because I don't want STATA to run everything from the beginning. So I highlighted the area I want and I play it. Then I can go back here and it is done. You can see line 13 do is showing that it's running from a do file. So I can show you in subsequent videos how to automate your do files, but that will be for another video. Let's focus on this. So let's go to the first part and sort of make sense of what this table is telling us. Remember, STATA will give you much more than you need. So this is the code. We can see there's survey tab VL Lumet class. So what did we have first of all? Age category. Now our age category is in two. Remember, we've adjusted for our survey weights. That's why we have the survey in front of it. So we have low met class 0 and 1. Now 1 is low. That's the way I've coded it here. So let's play along with that. And 0 is not low or high. Okay. And then age category 0 is 65 to 74, 1 is 75 to 84, and 2 is 85 and older. So I'll bring this my table back here into view and I start populating for low activity. Remember, low is 1. Then I'll write 772 here, open parentheses, that's 31.3%. 31.3%. I'll close my parentheses. Next line, it's still on this line. That's now, if I rearrange my code such that this column, this low metabolic class is not the header as this, then this result will be flipped the other way around. I'll show you in a minute. Let's finish this. 772 31.3, 710, open parentheses. I just like doing open and close and then insert in the center. And that will be 28.5. And then 508, open close parentheses, 21.1. I can take a quick look at my percentages. 5 plus 3, 8, 9. That means that something is missing here. Yeah, 31.3, 28.5, 21.1. It's just because of the proportions. That's okay. That's okay. 508. Another way you can look at it is your low. What's the total of your low activity category? N equals to 1990. I like writing this N in small letters. And then the percentage here will be what? We'll get back to that. And then so everything here must equals 1990. Now 8 plus 2, 10, 0, 7, 8 plus 1, 9. Yes, good. 7 plus 7, 14, 14 plus 5, 19. 1990. So everything here is complete. The reason why we have 99.9% is because of the approximations, which is okay. Yeah. And then for the higher activity class, then I go to the zero category. Zero category. Now, from 254, 254, that'll be 9.9. And then 141, that will be 6.2. And 69, that will be 3.1. Now, there's this column, there's the p-value column. And what's this p-value telling us? This p-value is comparing low metabolic activity, high or low, against age category. And interestingly, we have the result here as well. You can see here, the p-value here is 0.000. So what I usually write is, I write it on the first line. Because it's 0.0000, I write less than 0.001. 3 decimal places, 0, 1, 2, 3, less than 0.001. Let's do one more here before we go to the next table. So we can do race. Race One is non-Hispanic white, two is non-Hispanic black, three is Hispanic, and four is other races. Now we have this sorted out this way, and I will go back to this place and start fixing it. Remember, low activity is one, low is one. So I start plugging my values 1581, 1581. That is the count. How do I know? Look at the key here. The key is below. It's written here, key. Cell percentage is on top, number of observation is below. And if you are using the do file, you can also check that out here. The cell percentage is on top and the number of observation is below. You can see here. It's perfect. So let's complete this with the do file and see. So 1581, and that will be what? 68.9%. 68.9%. I really don't like writing percent again because I've written by percent here. So that should take care of everything there. Mm. And then as a rule, I just like leaving a space in between my numbers and the parentheses. 169, open parenthesis, close parenthesis, 5.3. And then the next is 145, open and close, and then 4.1. And then the last is 95, open parenthesis, close parenthesis, that's 2.6. I'm making everything to one decimal place. And then for the high activity will be 0. Anything low is 1, high will be 0. So I'm now writing this now, 381, open close, and then that's 16.3, 31, that's 1.1, 28, that is 1.0 because we have 0.99, so I'll just write 1.0, and then 24, and that will be 0.7. And we can see here, we also, like we are over 100%, 7, 10, 11, that's 100.1%, but it's because of the approximations. And some people will prefer that when you are having this, you sort of for example, if you kept this as 0.9, 0.9, then it would have added up, or we just leave, yeah, I mean, I'm not bothered about this at this point, so it's okay. As long as your ends are equal, which in this case is 464, n equals 464. Don't change the small n because the big N is the total population, which is 2454. 2454. Great. Now, what's the p-value here? Let's take a look at this. P-value here is what? You can see the p-value is 0.929. So it tells us that there's really no difference between the two groups. So I'll write p equals to 0.929. Let's make sense of this. Um, a quick one. As you can see, just taking a look at this, it appears that what we have here is row percentages, not row percentages, not column percentages. Very good observation. Now, let's fix that problem here. You can see here is 85.2. So we need to put an instruction that, hey, I need the column percentages here. So I will go back to this do file. That's why it's always just good to take a look at what you have and what's being generated and what you prefer. If for your paper or for the journal, this is the preferred way you want to report it, good. I typically do not report my results that way. So I like the column percentages. So let's do something. I'm just going to write the survey tab again. I'll copy this out, just this section out, and go to, I will change this to race. And then I want the column. So with the column, I can see here that, so this is the new results. I can see here that for the low metabolic class, it's 85.3%, 85.2 in the high, 5.9 for non-Hispanic blacks, 6.5 in non-Hispanic blacks, 5.2, 5.0, 3.7, 3.2. So there's really, really, really not much difference across the two categories. So that's why your p-value is so close to 1. So let's go back here. And I'm going to change all of these values. The number of observation is correct, but the percentages that we're having was not the column percentages. I prefer the column percentages. So I'm going to just fix it right away. So low metabolic is 1, and that's 85.2. And then 169 is 6.5. 6.5. And then 145 is 5.0. And 95 is 3.2. Now 381. Let's go to the next one. 381 is 85.3. And then 31 is 5.9. 28 is 5.2. And then 24 is 3.7. And as I usually do, I always just like looking at my numbers again. 7 plus 3, 10. 7, 10, 19, 20, 21. So one number here is jumping the boundary. And what was that number? I just want to see again. 8.4, 85.2. So this should be 85.2, no, it's 5.3. And you can see how I'm running my table just to be sure that I do not make mistakes. Okay, I'm looking at the wrong column. This is the activity column. So 85.3, yes, 5.9, 5.17, I've made 5.2, 3.65, I make 3.7. So some people will say because it's just 6.5, I can still make it as 6. I'm going to make it as 6, 3.6, and not round this up so that I can have my numbers to be 100% here. 3.6.3, 6 and 3, 9, 9 plus 9, 18, 20. Perfect. Now let's go to this next part. 2 plus 7, 5, 7, 8, 9. So I also had 99.9 here. So let's see what's happening here. Is it 5.2, 6.54, 5.01, 3.23. So 99.9, that's okay. So in some cases, I think you can just leave it at 3.7 here. It really does not change anything. So, but your p-value still remains the same, 0.929, and then you have 0.929 here. So I've shown you this way of writing your figures and being intentional every step of the way to be sure that you're writing what you intend to write, going back and forth that, okay, which percentage am I calculating? Now, the numbers can be whole lots, so you must be careful not to write the wrong ones. Just by looking at the last year, you can be sure that, yeah, am I reporting the particular section I meant to report? Um, and then you have your total population here. Now let's look at this. We have the total here. Remember, we're not reporting the total, but the total is also here. in this last column here. And that total essentially is what we've written before here. Look at it. 1962, 1962 is 5.2, it's 5.2, 200, 200, 6.4, 173, 173, 5.0, 5.0, 119, 119, 3.3, 3.3. So you can just use this table alone to populate everything here. Okay, good. Now let's take a look at our next table. So our next table is also like a bivariate comparison, dead and alive by age, just similar to what we've done before. So let's just do one and then we'll go on from there. So survey tab, let's start with race and dead, and then we can do column percent. Hmm. Let's see, what's the code? I can check the variable here. Is death not dead? Okay, great. Now, so if let's take a look at this. If I written my race, my death as the first variable and race as the second variable this way, this is the way it would have generated the results. But I want it to follow the same format I'm using here. So I will write let me just do this quickly. Yeah. So I will have I want the dead and alive variable to be on top. So that will be number 2 in the position. So I will make death to be after race. Then my survey tab is still there, and then these ones. So let's populate this. So here I'm doing the age category. I'm not doing the mean age. That will be for another video, essentially. It's a little different, but essentially it's also the same thing. Or I might just give you the code in a minute. So here, let's populate this. Let's populate this. So how many people? So death is 1. Okay, good. So for race, we're doing race. Then non-Hispanic white 871. Open close parentheses, that is 87.6%. And then non-Hispanic black 80. Remember, the lower part is is number of observation. The column proportion is the one on top. So column proportion here will be 0.1. And then 68 is the next. And then that's 0.04. Actually, I don't like writing 0.0. So but let's just for the purpose of this write 0.0. And then 40 is the next. And then that's 0.0. So let me just make it 2 decimal places. But for paper publications, ideally, if you're staying with 1 decimal place, stay with 1 decimal place. I will say 1 decimal place at this point. Okay, good. Now, 0 is alive. That is 1. 0 is alive. So now let's write that. 1091. And that is 83.3. 120. That is 0.1. That's 0.07, approximately 0.1. 105, then that's 0.1 also, and then 79, and that is 0.0, 0.03. So you can see that these numbers are so close, 87.6, 83.3, 0.1, 0.1, 0.0, 0.1, 0. So they are so close, and that's why your p-value is just slightly significant. So that's 0.035. 0.035. Why 0.035? 0.0346. So we're approximating to three decimal places. This is still significant because we have a large sample size, but then subtle differences here and then. So when you do your regression analysis, that will show whether it's actually meaningful or not meaningful. But at this point, this is what we are reporting. I said I will talk about this mean age. So let's do this mean age. So one long way of doing this is just by going to your data here, statistics, go to your survey data analysis, and then just go to mean, proportions, ratios, and then just the mean. So here, the variable you're interested in is age. And then you can click on this over. And what does it tells you? Over, that means that you want to, what is your stratification variable? If this is if in or over actually. So I usually use if, and or we can actually use this also. So let's use this. Depth indicator variable. That's where this will work. Okay. So this mean is being generated, I mean, over deaths. You can see this, and then it's telling us that those who are alive, those who died, 79.5%, those who are alive, 74.2%. So have this. Let's go back to this. Let's do this. And then dead is 79.5. Now, remember, one is right is standard deviation, but here we are getting the standard errors and the confidence interval, which is actually better. So can write the 95% confidence interval here, 79.0, 79.9, 79.0, 79.9. So here, since I'm not doing the standard deviation, I'll just write the 95% CI here, since that is what I'm reporting. And then for alive is 0. Then I can now write 74.2. And what's my 95% confidence interval? 73.8 and 74.6. 73.8 and 74.6. Do I have a p-value here? Technically, no. By sheer observation, you can look at it, but let's look at this code again. Interestingly, we might just be able to generate the code here. Reporting, let's go to reporting. 95% confidence interval. So if you want to change, you can change it to 95 or not 95% confidence interval. So and I think what we have here is sufficient. But if you really want to write the p-value, what I will usually do is to do the t-test. In this case, two-sided t-test. It's not at this point very important, but for consistency purposes, you can do that. So so for this t-test, for this p-value, it will not account for the survey weights. So usually when I write it, I will put a note there for the readers that this is not a survey weighted p-value, but the confidence interval is survey weighted. So classical test of hypothesis. So the t-tests comparison. So what are we selecting? Two samples using groups. The group name will be deaths. The age, the variable will be age. And then I can click on submit here. And this is what we've gotten. You can see that the numbers are almost equal: 79.3, 74.3. This is not accounting for survey weights. So let's see, 79.5, 74.2. You can see the slight differences. So the p-value here, because it's non-directional, you choose one in the center, less than 0.001. So less than 0.001. In some cases, you might choose to just leave this out since you reported your confidence interval. By eyeballing this confidence interval, you can see that this confidence interval does not even cross this. So you really do not need to write a p-value here. But then just for the purpose of this training and maybe for your interest in your own paper, you can write it there this way. Some people might also compute the mean age here without necessarily reporting the standard deviation here. But look at this, we have the standard deviation in this place. But remember, this is not adjusting for survey weights. Okay, now that we have table 2, essentially in table 2, we've done the variables that are categorical, and we've done the ones that are continuous, mean age, and then this standard, these confidence intervals. Let's take a look at table 3 also. Now for table 3, for table 3, this is where you report your unadjusted and adjusted odds ratio or hazard risk. In this case, we did an hazard risk, Cox proportional hazard regression analysis. Future videos will show how this is done, but I'm just going to show you some of the results here for the purpose of generating the tables. So I'm going to copy this or just run it from here. Survey, linearize, ST Cox, low met class. Remember, for Cox proportional hazard regression analysis, there are different there are different steps for you to do before deciding that I'm going to just the Cox proportional hazard regression analysis. You must also have adjusted for your um for your hazard regression, and that's I had done before, so I'm not going to go back into all of those steps at this point. But for the purpose of generating our tables, here it is. And this goes for every form of regression analysis. Now, for the unadjusted hazard risk, the one will be the low metabolic class. The 0 will be the reference category, which is the high activity. So not low. I can also change this to high just for consistency purposes. So here I'll write this as my reference value, REF. And the unadjusted is this. Why is it unadjusted? Because the only thing that I'm running here is a low metabolic class. My predictor is already embedded in this ST Cox, in which I had declared it to be a regression analysis. I've told STATA that in this ST Cox, deaths as with the variable with the index being 1 is what you should use, and the time to death, I've defined that also using LOS, using the length of the follow-up period length of stay. So here, this is where I've declared it. So I will do that in future videos. The follow-up period, I've declared it here. So let's generate this table. So I'll always write the reference as the one that is not being computed. Stata does something. The lower value will be the reference category. So if you want to flip it, make sure you flip before doing it. What do I mean? Now, here, low met class is 1. High met class is 0. So 0 is used as a reference in this situation. Now, if for example, now let's do something a little different. For example, race. So let's see what race tells us. I'm going to play it here and come back here and can see. Race, there is no 1 here because 1 is the lower value here, so it's the reference value here. And all of this is being compared to the reference value of 1. So I have my ref here, and then have my ref here also. But let's do the unadjusted first, since that's what we are doing here. So the unadjusted is 1.988. So I'll make it 1.99, 2 decimal places, 1.99. And then open with parentheses, 95% confidence intervals. I'll go to my 95% confidence intervals here, which is my 95% CI here. I really, at this point, don't need to write all of this here. So this is 1.62 to 2.44. 1.62 to 2.44. Is this statistically significant? The answer is yes, because it does not cross 1. That means that this 1.6 is above 1, and definitely, and this is a lower value, and this is higher, 2.44. So it didn't go from 0 point something to 2 point something. It's this 1.6 is above 1. And consider, although this is statistically significant here, which is the way we interpret the confidence interval, the p-value is also significant. It is less than 0.05. In fact, it is less than 0.001. It is 0.000 here. Perfect. Now let's fix the one for race. For race here. Now look at race. The hazard ratio is 0.925, and that's 0.93. That is non-Hispanic black compared to non-Hispanic white. But look at the confidence interval, 0.72 to 1.19. This is crossing the 1 mark, so it is not significant. And the p-value also suggests that this is 0.541. But look at this next one, Hispanics, 0.73. Confidence interval 0.55 to 0.97. This is significant, statistically significant, because it does not cross 1. This 0.97, which is the upper boundary, is less than 1. So, and you can see the p-value also 0.033. Let's write our results. I'll go to this here. I'll write the non-Hispanic white as a reference category. Remember, now I'm writing the non-Hispanic white as reference category here because it is the lower value. So let's write the number 0.93. Move this a little bit to the side. Let's move this a little to the side also. Can I just reduce this? I guess I can. Good. So I can see both tables here. So 0.93 and that's 0.72 to 1.19 is not significant. And then 0.73, open parenthesis, 0.55 to 0.97 is significant. Other raises 0.65, open parenthesis, 0.43 to 0.97. Usually, I will bolden those that are significant, and just for readers to be able to know that this is significant. And I usually write below that significant results in bold. So I can write it here, that significant results. Significant results in bold fonts. Great. So let's do something. Let's do the order column. This column is the adjusted column. That means that everything here, all the variables together are being added together. So this is table 3 on adjusted risk ratio. We have all the results here. But let's now have this. This is adjusted risk. And we have all these variables inside plugged together in one single model. Then let's have our play button here. We already have the results here, but let's look at it here again. And you can see all the results are here. So we'll do just those two for the purpose of this tutorial. So activity low metabolic class is now 1.6. I'm going to move this a little bit here. Okay. So now we have 1.64, open parentheses, 1.32 to 2.03. And you can see that even after adjusting for everything, these values reduced but still remain significant. I bolded it to show that it's significant. And the p-value here is also significant. This confidence interval does not cross 1. The lower value is above 1. Let's do race also. Non, that's 2, 0.88. 0.88 here. Initially, non-Hispanic black was not significant. Now it's still not significant, 1.15. Good. Next, 0.97. Now look at what's happening to the Hispanic population. Here, 0.97 and then 0.72 to 1.30. No longer significant. In the adjusted model, it is no longer significant. So I'm not going to bolden it. The next is 0.77. That's other races. Open parentheses, 0.52 to 1.14. And this is also no longer significant. So in the unadjusted model, these two variables were significant compared to non-Hispanic whites. Hispanic other races were significant compared to non-Hispanic whites. But in the adjusted model, it is no longer significant. So, and for activity intensity, it was reduced, but still remained significant in the adjusted model. So we'll stop at this video at this point, and we'll make additional videos to talk about different aspects of the regression analysis. Please comment and raise questions, and we'll sort of figure it out from that point. Thank you.